If you're in the world of research, you definitely know the name, LaTeX. It's the gold standard for writing professional papers, no doubt. But it's also famous for one other thing, turning the simple act of writing into an all-out war with your computer. So today, we're going to talk about how to finally tame that beast.
And I mean, this quote just hits the nail on the head, doesn't it? It perfectly captures that core frustration. You're trying to push the boundaries of knowledge, you've got these incredible ideas, but instead, you're stuck for hours, sometimes even days, fighting with an error message that looks like complete gibberish.
And this leads us to what I call the LaTeX paradox. See, on one hand, it's this incredibly powerful tool that promises these absolutely beautiful, professional-looking documents. But on the other hand, well, the road to get there is paved with some of the most infuriating error messages imaginable.
And this slide just lays it all out. The promise is that gorgeous, clean paper that's ready for publication. But the reality, well, it's that wall of red text. You know the one. Cryptic messages everywhere, and you have absolutely no idea what you did wrong. Your entire research flow just grinds to a halt while you're left staring at a log file.
Okay, so to really get a feel for this pain, let's just run the gauntlet. We're going to do a lightning round of the most common errors that completely derail researchers. Think of it as a quick tour through a minefield of syntax traps just waiting for you. First up, the undisputed champion of all LaTeX errors, missing dollar inserted. You have all seen this one. It almost always happens because you used a character that's meant for math, like an underscore, or a Greek letter like alpha, just in your regular text. LaTeX sees that, it completely panics, tries to force everything into math mode, and the whole document just breaks.
All right, next on our list, undefined control sequence. This is your classic typo error. You accidentally typed /Zelfa when you meant /alpha. Or, and this one's a bit sneakier, you tried to use a command like /insert graphics, but you completely forgot to include the graphics package at the top. Either way, compilation stops, dead in its tracks.
Then there's the incredibly frustrating file not found error. It's like, you know the image is right there, you know your bibliography file is in the folder, but for whatever reason, LaTeX just can't see it. This usually comes down to a simple mistake in the file path or, and this one gets so many people, case sensitivity. Yep, myfigure.png with a capital M is a totally different file than myfigure.png with a lowercase m on a lot of systems.
And let's do one more for this tour of pain. Misplaced alignment tab character. This guy pops up whenever you use a regular ampersand, the and symbol, in your text. See, LaTeX reserves that little character for aligning columns inside of tables. So if you just want to type research and development, you have to remember to escape it by putting a backslash in front of it. So easy to forget. And boom, another error gets added to the pile.
So, you've hit one of these errors, or let's be honest, probably 5 of them at once. Now what? Well, for decades, the process for fixing them has been this unbelievably tedious manual maze that just pulls you completely away from your actual work.
And this is that traditional, painful workflow. First, you try to decipher the log file, which is basically impossible. Then you copy-paste the cryptic message into Google and just pray that some kind soul on Stack Exchange had the same exact problem. If that fails, maybe you start digging through older, working versions of your file. And the absolute last resort, the binary search. Commenting out half your document, then a quarter, then an eighth, just to find that one misplaced comma that's breaking everything. It's a colossal waste of time.
But what if there was a better way? What if the editor itself was actually smart? Smart enough to not just find these problems, but to understand them and just fix them for you? Well, this is where the entire narrative takes a major turn.
So, let's talk about Bibby AI. Now, the key thing to get here is that this isn't just another editor where they kind of slapped an AI feature on top. No, this is a native AI-first editor. It was built from the ground up, from day one, to be an intelligent partner in your research process, with AI woven into its very core. And it directly attacks all those pain points we just talked about. It has a context-aware AI that actually understands your document. It has smart citation search built right in. It can auto-generate complex tables and equations from just a plain English description. And, most importantly for our discussion today, it explains and fixes those cryptic errors we just walked through in plain language that a human can actually understand.
Now, that all sounds fantastic in theory, right? But the researchers behind Bibby AI wanted to prove its effectiveness with hard data. So they decided to put their AI to the test against the very same errors that plague researchers every single day.
Which of course leads to the natural question, yeah, but how much better is it really?
It's one thing to make a claim, it's something else entirely to back it up with a rigorous, academic-style comparison.
To answer that question, they created something called LaTeX Bench 500. Now, this isn't just some random collection of mistakes. It is a standardized benchmark of 500 authentic, real-world compilation errors, covering everything from math mode issues to package conflicts. This allows for a true apples-to-apples comparison of different error-fixing solutions. And this, well, this is the hero slide right here. When they tested it on that benchmark, Bibby AI achieved an 83.7% one-click fix accuracy. Let that sink in for a second. That means for over 8 out of 10 real-world errors, it provided a correct working fix with a single click. Now compare that to a general-purpose model like OpenAI Prism, which came in at 64.1%. That's a huge performance gap.
But it actually gets even better. See, fixing an error is one thing, but first, you have to find its true source. Bibby AI had a 91.4% accuracy rate in just detecting the error's location and type. And this is so crucial because, as we all know, the line number in a log file can be completely misleading. This super high detection accuracy is the foundation for its effective fixing ability.
So, what does all of this mean? What's the big takeaway? It points to a fundamental shift in how research papers are going to be written. We're moving away from a world of manual debugging and into a future where our tools are truly intelligent assistants.
And this really says it all. The whole point is to move from spending your valuable time and mental energy on debugging syntax to focusing on what actually matters: your discovery, your methodology, your ideas. The goal is to eliminate what the creators call formatting anxiety and just let researchers get back to the actual work of research.
So that leaves us with a final, thought-provoking question. If an AI coworker could handle all the tedious, frustrating parts of writing a paper, freeing up hours or even days of your time, what new discoveries could you make with that freedom?